Welcome friends, thanks for joining this 1-hour webinar on business analytics, multivariate linear regression. We'll wait for a few more minutes for friends to join us. Till then, can you hear me okay? Webinar has not yet started. Just checking with you guys. Can you hear me okay? Ali says yes. Anil says okay. Good. Danish says yes. Okay guys, let's wait for a few more minutes. That's it. And then we'll get started. Okay, so few of you are saying let's start, so it's time to get started. Thanks for joining this webinar. This webinar is a continuation of the other webinar that we did, which talks about multivariate linear regression. Remember, we started with a case study that there is an auto insurance company, right? And I was given a task that the loss or the claims, insurance claims that happen, identify the independent factors or the factors which are responsible for these losses. And since there are more than one variable responsible, it's called multivariate linear regression. And of course, we are going to help Adam, who is building this model. Okay. And we try to massage our data, normalize it, remove the redundancy. We came up with a point where we have a clean data. Okay. Now today we are going to talk about, if we have the data, how to perform a multivariate linear regression. And you know what? We'll use a software called R software. We'll download it right here in front of you. It's a freely available software. We'll download it, use it to do the statistical analysis. Okay, so before I go ahead, a quick introduction about EduPristine. It's a key authorized training provider of CFA. The CFA, which is the golden certification in finance across the world. If you go to their site, you will see EduPristine is an authorized training provider. Similarly for GAAP, that's the body that set up the FRM, the financial risk management, and we are authorized training provider there as well. Association with FPSB India for CFP training. Primia, this is the body that organizes PRM and APRM certifications. Pristine is an authorized training provider there as well. The key associations with a lot of big banks in various training sessions. There are testimonials from VPs, senior management, senior executives from all these banks where these trainings were conducted. Not only the organizations, we have association with universities. So the top universities of various countries are being associated, not only to deliver the course there, but to develop the content. Online presence across the world with training centers at Singapore, Middle East, that's what we are targeting, USA, and all the major cities of India. Okay, so we are back to our educational content. Once again, feel free to post any questions in the chat window. Okay, I would like to answer all the questions. In case I'm unable to answer, we will definitely drop you an email with the answer, okay, or give you an answer in the chat box, okay? So make sure you put your email ID if your question doesn't get answered, and we'll pick that email ID to answer that. Okay, so you know what? I've just got 5 or 6 slides today. Not much theory. Today is the practice session where I'll actually download a software, develop the input file for that software, come up with the output, and analyze the output, and then we are done. So it's a short and complete practice session today. So how many of you remember what we did in the last webinar? Here is the quick summary. Adam was given a task. His idea was that he needs to identify for an insurance company, which is the dependent variable, the losses or the claims. What all factors explain those claims? Insurance claims depends on the age of the driver, the age of the vehicle, the characteristics of a driver, whether he is married or maybe whether how many years he has driven the car, okay, his gender, whether it's male, female, what's the fuel type of the car, all that were independent variables. We need to categorize which ones are categorical, like married or unmarried, discrete, fuel type, continuous, maybe age. So we come up with certain variables, and of course we remove the outliers from our response variable. So we cap and floor the values at the threshold. Not only that, we looked at independent variables for any multicollinearity. What's multicollinearity? If there is a correlation between independent variables, then I know I can only use one variable, one independent variable to represent my dependent variable, okay? So if there's a correlation between independent variables, I don't need both of them. I can drop one of them. And you remember how we dropped? Any one of you who has looked into that webinar, how we dropped an independent variable? Here it is, multicollinearity. The way we dropped an independent variable is to first find out the correlation between the variables. For example, age of vehicle and the age of the driver and the driving experience of the driver. Okay, we found how high correlation between the age of the driver and his driving experience. Hence, we found there's a multicollinearity. Then we ran a bivariate regression where the dependent variable was losses, independent variable was, initially there was one independent variable which was the age of the driver. Next time it was the driving experience. And we found that driving experience was showing a higher R value, R square value. Okay, R square value was high in the regression with driving experience. So we picked that variable, dropped the other. Okay. So we keep fitting the regression with one variable and dropping the other variable. That's all what we did. But today, we assume we have cleaned the data. We have got the right data. We have got all the variables with us. There is no multicollinearity. There is no heteroscedasticity. If you really want to know how we remove that, look at the other webinar. Today's webinar says you have fixed heteroscedasticity, you have fixed multicollinearity. Now you have 6 variables, independent variables and 1 dependent variables. How would you perform? a multivariate linear regression using R. R is the software. Don't confuse R with R square. R is the name of the freely available statistical package, and that's we're gonna learn. Before I go there, let me show you where we were. These were the variables we had from last time. There was a policy number, and this was the dependent variable. The capped losses is the dependent variable. Okay, the losses that someone gets, the insurance company, when people claim for these losses, this is my dependent variable. Okay, and rest, for example, average age of the driver, the gender, remember the gender was converted into a dummy variable. 1 means male, 0 means female. Similarly, married, unmarried, another dummy variable. Average vehicle age was taken, so we converted into band and took the average age. That's all part of previous seminar. Fuel type, so we again took a dummy variable 0 and 1, categorical, right? So we've got how many? 1, 2, 3, 4, 5, and 6. We've got 6 independent variable, and we have got 1 dependent variable. There's a question by Joseph. How do you differentiate between 2 categories of dummy variables? So there are 2 categories of dummy variable, let's say fuel type and married. How we differentiate? Because there is a name, there is an attribute associated with this. Okay, the married and the fuel type. Okay, so when we will come up with a linear equation, regression equation, it will say married into something, fuel type into something. Since we do not lose these names in the equation, a 0 with a fuel type is different than the 0 in a married type. Okay, so you will soon see, even though the numbers are 0, 1, 0, 1, since we keep their tags along with them, we can differentiate. Does that answer your question? And we, independent of anything, assign 0 to diesel and 1 to petrol. Okay, so you can decide what you want to put for 0, what you want to put for 1. Just remember what you have done. Okay, so this is what we did last time. I can take you quickly that this is from where we started last time. Big data, we come up with bands, age group, vehicle age group, performed small regression analysis, right? We performed this regression, and found that one of them, years of driving experience, has got a higher R-square value. Remember? And we said, let's pick this independent variable and drop the other. Based on that, we come up with this. Okay? I hope we are all set to launch ourselves into the R software. To download and install the R software, which I'll do right away, is actually to go to this site, rproject.org. Even though I have already installed it, I'll just show you how to do that. So what you're going to do is go to Google and let's call it R project. Just search for that. The very first link is for rproject.org. Here you got this. This is the freely available software. You want to read what's R? You can do that. Okay, right here there is a link to download R. So I click on that and it says, you know what, find the country where you are located. And I'm located in India, so I'm going to search for India. Can you see that right here? So you click on this, it will ask for what platform. Is it Linux, Mac, or Windows? And I'm using it for Windows, so I press download R files. Now it's just asking whether you're installing R for first time. Press this. Yes, we are installing for the first time. The top link, download R301 for Windows. And you know what? If you look at the bottom, it's downloading, it's taking time. Okay? So while it takes time to download, it's a 51.6 MB big one. While it takes time, let me show you how to use it. Step 1 is to download, and it's happening in the background. Step 2, I need to convert my data into R readable format, which means that this software does not take Excel directly. I need to provide a format, and the format is a comma separated file, .csv. I need to convert my Excel into a comma separated file, .csv, and I'll put that as a data in certain path, for example D drive here, okay, and then I will launch my R. Okay, so let's jump to step 2. Step 2 is, here we have the data in Excel format. So what I'll do, I'll say Control A, select everything, Control C, copy everything, and start with a new blank workbook. Here I have a fresh workbook. Okay, I do a paste special. Don't just paste, paste special. The shortcut is Alt plus E plus S. Okay, so you're gonna press Alt E S, and that's the shortcut for paste special. Okay. Oops. Here I am, Control A, Control C, the whole thing is selected. Where is my, hold on. Yeah, here is my total window. I press Alt E S, and it asks for, I say value pasting, it pastes everything. Can you see that? It's another Excel file with just the data that I want. I delete all the things that I don't want. These are all, you know, trash for me. I just remove that. I don't need this. Even receipt I don't need. Not even all these guys count this. I don't need all that. All I need is one dependent variable called cap losses, and rest I don't need. What did I remove? So I'll just check. The cap losses is there. Yeah, I removed even the losses, and policy number is there. I don't need that even though. But now I have how many? 6. 1, 2, 3, 4, 5, 6 independent variables and one dependent variable still in the Excel file. Now I save this file as a .csv file. How to do that? Save as. Put a nice name here. So let me call it sample data. Sample data, no space, nothing. Remember the name here, sample data, and there will be a format called .csv, comma separated file, and I say save, and it will say something is not supported. Okay, don't care. May contain features not compatible. Okay, yes, go ahead. And you know what? Let me go and show you where this file is. Here it is, sample data. This is what we saved right now. That's the time, India time. You can see that. Now you can do a right click and say open with a notepad, and what you will see is a comma separated file. Can you see that? Policy number, comma 1, comma 20, tick, 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 all the data. Okay, so that's the comma separated file. Looks very strange to me. I hope this is fine. Okay, so this is the data and this is the .csv file I have created with a name called sample data. Okay, so that's the first step of cleaning and creating a .csv file. Let's look at where is our download right now. Oh, here it is. I have already downloaded it. Asks for run. I am installing our software. So I say run. Yes. It asks for language, English. Next. Yes, next. I like this path on program files. Next. It says it already exists. You know, I have already downloaded it, but let me install that folder anyways. So I say yes. It asks for all the binaries. Yes, 32, 64, everything. Next. Accept defaults. Next. R. Do you like this name? I like it. Let's call it R. A desktop icon. Yes, I need it. And here it starts. Automatically close the application and let's say next. It's closing any application which is using R. I have this R open, so let me close it myself. Just to tell you, so I'm just closing it. I don't need anything. Here it goes. It's extracting files. It's gonna take time, but it is installing a software called R. Okay, so once again it will take few minutes and I'll jump to the data that I'm preparing for R. Remember, I have this sample data. Yeah, here is my sample data. Can you see that? .csv. And you will soon realize to give an input to an R, this is what you have to do. You have to read this file, okay, read.csv, and you have to read it from the path right where you have saved it. So I saved it in an E drive under a folder called analytics, and my file name was sampledata.csv. So I first write on this software, you know what, this is the object. I can give any name here. Read.csv is the keyword. Read the CSV file equal to, which is located at this path. Okay, remember when you say the path, you give double backslashes in the path. Why double backslash? Because one backslash is a special character and you give another to remove the speciality. Okay, so even if you do not understand that, just remember all the paths that you give must have separation by double backslashes, and this way I'm gonna read this file. Okay, once I have read this file, what I'll say is another object, my own name, I could have called it fit regression, and this is the keyword LM. LM is the keyword to do multivariate linear regression. Look here, I give the dependent variable cap losses, put a tilde here, a tilde, how a tilde looks like, a tilde on your left top corner of keyboard below escape. So I give this nice tilde, and that means after this point the independent variables start. So I give the name plus another name plus another name and keep giving the name of all these 6 variables, then a comma, and you know what, the last argument is nothing but my user defined object where I have read the data, linear reg data. Okay, so once again, you first read the file in an object, give the path of the file, we will learn the syntax soon, Once you have done that, use the keyword LM, and you need to put the names of the variables. Remember, we are keeping the names so that I can differentiate. The names do not have spaces. That's another interesting thing. So I have underscores, not these spaces here, and I put a plus sign. Last argument has to be the argument which has read all the data. Okay? Let's see where we stand. Oh, it is still extracting. It's about to happen. Let me see if there are any questions so far. Roshan is saying, is it a trial version? No, Roshan, it's a full software. It's not a trial version for limited time. You can download it. It's freely available software. Joseph says, I don't see download for 32-bit. Why? You should have seen that. Remember, I have downloaded in front of you. So it gives you 32, 64. You select both. And Ali says, I do not understand Alt-ES. Ali, if you copy in Excel, let's say you are copying in Excel sum of few variables. So if I say sum of these 5, right? The sum is 1, which is sum of these variables. If I copy it, Control C, and paste it, Control V, it copies the formula. Can you see another sum? The value is not copied, the formula gets copied, and the formula gets copied relatively. See, it has moved this guy to this point. The earlier sum was this. When I copy pasted, it became on right. So one way to make sure I'm copying 1 from here to here is to do a special copy where copy is copy by value, not by formula. So how to copy by value? Control C, copy. Now while pasting, I'm using a shortcut called Alt-ES, and it opens a window. And it says you want to copy using formula, values. I would say yes, copy the value, don't copy the formula. So when I say copy values, it makes it 1. And see, there is no formula behind it. There's no formula right here. Can you see? It's just 1 getting copied from here to here. Does that help? Alt-ES, shortcut for paste special, by value. A quick check. Roshan, did you get your answer? Joseph, Ali? Yes from Joseph, yes from Roshan. Still waiting for Ali. Ali says yes. Okay, we are doing good. Look. The whole guy, the R is installed, and I say finish. So while we were talking, R got installed, and I go here and see, oops, right here there's an R. A big R is our software, and I double click on that. And I got a console, a very nice console. It starts with this. Here is our software. Type Q to quit R. I'm not going to quit right away. Now here is the prompt in the R. Now if I look at right here, this little thing, this right here is little thing is the prompt. You're going to put this thing, the reading of the .csv file. Are we all set to read it? No, before actually reading, let me change all the names, remove their spaces, put an underscore. R likes underscores, not spaces. So what I'll do is, I'll say Control F. Control F is the shortcut for searching and replacing. So I say replace. Replace what? I say a space. replace space with an underscore. So I put a space, find what, and an underscore, and say replace all. It says it has made 11 replacements for me. Okay, I like that. Close. Look here. All the names, instead of having spaces, now they have got an underscore. Can you see that? That's what I wanted. All underscores. Now I save this .csv. Once again, yes. Okay. So I've got the .csv sample data. Where is it stored? Let me go to the folder. Well, you can see on my computer, it's stored in E drive with a folder called Analytics. So once again, E drive, and that's Analytics folder, and here is my sample data. Remember this path. Okay, I'm going to R, and you know what? I'm going to create my object, and I say reg, be careful, it is case sensitive, so R caps reg data. Okay, remember I give an object in the beginning. Let me clean everything. I'm gonna give object, and then this is the keyword. Okay, an arrow key with the read.csv. So that's the keyword. I would also write same thing, read a CSV file where file is equal to the location of the file. I start with double quote E colon path analytics. Remember my folder, analytics backslash. What was the name? Sample data.csv quotes, close the bracket. See, I have given double backslashes at the point. So I'm doing nothing but just saying, you know what, put a bracket, file equal to the path, bracket close. Okay. Anil is requesting for the sample data. Anil, we have posted a blog on this, and there is a link to extract the sample data. I would request you to go to the blog and download it. I cannot stop the webinar to give you the sample data, but please go at the blog even right now, or you can do it after the webinar. Okay, so I have typed the command to read the data, okay, and I press enter. Nothing happened. If nothing happens, it's a good news. Otherwise, there would have been an error. I have seen errors sometimes because the path is incorrect, the file name is incorrect, or you have not used the read.csv, the read command. Okay, how do I know that it has read the right data? Summary is the command to know whether everything is being read. Summary bracket start my reg data. All I'm saying, give me the summary of what you have read, and it has given me a summary. What is it saying? Let me see, not a good summary. No. I was expecting mean, median, mode for all these guys. No, data is not in the right format yet. I need to go ahead and see. I should remove all this. Let me pick and see what is the difference. It should start from top and all the data each next to each other. Let me fix this here, and I say shift space bar to select all the above rows and control minus to delete the rows here. And this is the column I don't want. Control space bar, control minus, just remove this. Okay, and remove this one as well, delete this row. So I've got everything in a row next to each other. Okay, and then we have data till 15291, which is fine, and everything is arranged. I hope this is right data. I save it again, Control S, yes. Let me go to R, and I want to read it again. How to read it again? One way is I can type the same command again, or I can press, I can actually see if I can copy this, Control C, and paste it, and press enter, and it has read it, and then say summary reg data. Now it looks good. This is what I wanted. So what I did, I actually made a mistake that I left some rows at the top and some columns on the left. I should not leave any row. The very first row should be the header, and next row onwards I should have values. The very first column should have one of the variables. Okay, so I just removed the extra rows and columns and read it again, and you know what? I got the summary as policy number. This is the mean, median. I don't need this first data, just redundant. Number of vehicles. It says this is the mean, median mode, average age, all the variables, till cap losses. So all this shows me is our software has read the data right. I am happy. Data has been read. Now I want to do multivariate regression. Don't you want to do that? Let's go there. How to do that? Here is the equation. Put any object and use a keyword called LM. Then what is this? Dependent, and all independent variable with a plus sign, and finally this object. Okay. Now one trick I will do here is I want to use all these variable names. I don't want to make any mistake, guys, in the naming. So what I do, I use a small trick and I say, let me concatenate. Concatenate the first variable that I want, number of vehicles, right, with a plus sign, space plus space, okay, and equal to. And see what has happened? It has concatenated the first variable with a plus sign. And similarly, I go to the next column, my one column, and say equal to, concatenate what? Concatenate the previous column with average age this time, and also put another plus sign in front of it. Okay, let's see what I've got. Oh, I've got plus 2 guys, and their names are taken from the data. Now what I do, I copy this. It will always concatenate what is on its left, whatever, relatively on its left, with the next variable, and put up a sign. So I copy this, Control C, go on the right, maybe 4 times, 5 times, and Control V, paste it. The last one, look here, where is my last one? Right here. The last column, when I do a relative copy, actually contains all the variables I needed. Number of vehicle, average age, gender, fuel type, dummy, cap losses. I don't need cap losses in my independent variable. So I copy this, Control C, go down, value copy, paste special, Alt ES, opens this window. Don't copy the formula, copy the value. And I got this value right here, and let me fix this value and then say I only need 6 variables, 1, 2, 3, 4, 5, 6. Press enter, and I got what I needed. You like it? I'm not making any mistakes with the variable name. I need all this because unfortunately I have to pass this data right here. Can you see? I have to pass this data in our software. all the independent variable with a plus sign. Okay, so I've created here, let me copy this, copy. I'm not changing my CSV file. I'm not saving this. I do not want to save this. Okay, I just copied it and I say fit fit the regression, my own name, you can give any name, then this guy, a special keyword, and then LM, bracket start. My first one was capped losses. Make sure you give the same name. Then a tilde, and then all the independent variable with a plus sign in between. I have copied that and now I'm pasting it. 1, 2, 3, 4, 5, 6. I've got all the 6. Oops, it is going to the next line. No problem. I say comma, and I have to give the reg data, the object where I have read, close the bracket. This plus sign, I have not given it. All it is saying, this plus sign right here. All it is saying the next line. I press enter, nothing happens. Good news, there is no error, and behind the scene, the multivariate regression has been performed. Can you tell me how to look at what it has done behind the scene? Any one of you? Any guesses? How to look at? Yeah, summary, the object name fit reg, same as before. Remember the object name that I have given, so I do a summary, and look what I have got. I have got a multivariate regression results. Here are all my variables on the left. Can you see that? The intercept of the regression, the coefficient of the first variable, the coefficient of the second variable. I've got the standard error, the t-value, and the significance. Remember the alpha or the significance of this value. And I've got some stars here, 3 star, nothing, 3 stars, 3 star. Now, the only thing left is to understand this data. I have performed my multivariate regression. Okay, let's interpret this data. Every linear regression is a linear line equation. Okay, the intercept of the line, the point where it hits the y-axis when x-axis is 0, these are the x-axis variables. There's one variable, there are 6 variables, and this is the constant, the coefficient for every variable, the standard error of the sample. The t-value is nothing but estimate divided by standard error. Okay, t-value. These are the t-values, and you look at the significance level. The lower is the value, the better it is. Okay, higher significance with the lower value, and these stars here says that, you know what, 3 star means it is the most significant. Very good, keep it. 2 star means 0.001 significance. Okay, 99.999 confidence interval. 1 star, okay, is 0.05. Single dot means 90%. A space means not statistically significant. So here you see a space, which means it is not statistically significant. Number of vehicles have got a space here, a high value, which means that this is not statistically significant. So what I'll do, I'll look at this data and copy paste back into my Excel, because my answers are going to be in Excel. So I also look at that the degrees of freedom are 15283, which is going to be 7 less than the total observations. So my observation were 15290. Let's look here. Can you see 15291 is the row number? It starts one less. So 15290 is the total size of the sample, and I always have the total size of the sample n minus number of independent variables, which is going to be 6 here, minus 1 to get the degree of freedom. Here I got it. R square, the explanatory power of my independent variables, R square, or the adjusted R square, rate high 75%. That means 75% of the capped losses are explained by these 6 variables in this regression, multivariate regression, and that's good. That's good number. So what I do here is now copy these guys, Control C, copy this, go back to my original Excel, maybe this one, and go to the fresh sheet, paste it. So I've got all the data here. Can you see that? Now this data is in one column. What I'll do, I'll go to data, I say text to columns, and I say fixed width. Let me pick, just hold on, let me pick the right column which has everything. Text to column, no, I need to, let me copy paste it again. It's not getting copied in one column. So I say let me pick this, Control C and Control V. They are in different columns, so let me select it whole. Text to columns. Is it happening? No. Text to columns, fixed width, next, finish. So I got this in different columns. Then I pick next one, next to columns, fixed width, next, finish. Now these are in different cells. Can you see that? I need to do it for everything. Text to columns. I selected all of them, next, finish. Now I converted the text into columns which are delimited by spaces. So can you see that? Nicely arranged. This guy is called the first one is called the coefficient, the next one is standard error, third one is t-value, and this is the significance level. Okay, I remove this guy, it has no meaning right now. I can compute the t-value on my own. The t-value is nothing but coefficient divided by standard error. I can do it for all variables, and you know what? I got t-value which is same as the values given here. Can you see that? Same values. Okay, I can also compute the lower interval, 95% confidence interval. Okay, and I can also compute the upper 95% confidence interval. Okay, if you want to compute that, you can compute this. The formula for confidence interval is coefficient minus 1.96, that's 95%, into the standard error. So that's the lower side of my confidence interval. The upper side is nothing but coefficient plus 1.96 into standard error, and that's the upper range of confidence interval. Okay, there's a rule of thumb that if confidence interval changes sign, the lower and the upper, if there's a change in sign, most likely this is not a significant quantity. Rest of them have same signs, the lower and upper same sign, same signs. Here the sign reverses, most likely it's not significant, and we already know number of vehicle is not a significant. I need to drop it. Rest are significant independent variables, I'll keep them. Now I'm gonna drop it. So I go back to our software, okay, and this time I'm going to press the up arrow key. When you press the up arrow key, okay, it actually brings back the same formulas that you have used in the history. Up arrow key, and I go here and I say, you know what, let me drop number of vehicles. So I go here and I remove this guy from my equation. There's no number of variables. Fuel type dummy is the last, then I put a comma and I put my reg data, the first object where I have read. Remember this guy right here? A reg data is always put in the end. So I've got everything but removed number of vehicles. Press enter. Nothing happens. Good news. No error. Again do a summary. Fit reg. You know what? I have got 5 variables and 1 constant. All have highest significance. Triple star rating. I like this rating. And I copy paste this whole thing till the end. Control C, copy. Go to the Excel and I say regression 2. Regression 2 with only significant variables, and I paste it. Once again, the data is here. What I'll do, I'll select this, go to data, text to columns, like it, finish. Here I get a nicely arranged data. I don't need this triple star rating now. I can actually compute the same stuff, right? The same stuff, lower, upper for this guy, okay, in the right row so that I get the right answers again. So I do it. Oops. Yep, same sign. Everything is significant. I've got the confidence levels. Let me remove the red color now. Okay, so I got this data, I got the coefficients. Our software has able to help me, right, to provide the explanation of dependent variable on independent variable. This is my final answer from the package. We did it from scratch. Nothing was given to us. And my boss is happy because my output is like this. Okay. And all I'm going to tell my boss is, what's I'm going to tell to my boss? I'm going to tell him that I have got these variables. This one is removed, so let's remove it. I'll say intercept is 624. Average age, it has a negative sign, which means that as average age increases, the losses reduces. Gender dummy has got a positive 50 sign, okay, a positive number. Married dummy has got a big positive number. So if the gender is male and the guy is married, he has got a higher chance. Average vehicle age is negative. So as the age of the vehicle increases, there are lower chances of losses. Fuel type, one kind of fuel gives a higher chances of capped losses, which is my dependent variable. Let me pick up the final answer that I would present, right, and how it will look like. Just give me a minute and I'm going to show you a table which is the answer to this problem. It's a nicely formatted table. Give me 1 minute to come up with that table. So I'm opening the blog link that explains all these steps. And one of you were asking for the data that is used in this webinar. I'm going to the EduPristine blog on learning linear regression in R. Okay, so here is the R project, here is the data, CSV file. You keep moving down, and here is the presentation of the final answer. So we got the same answer, intercept, coefficients, average age, higher is the age, lower is the loss. Gender dummy positive, males is higher than females. Married, single is higher than married. Vehicle age, older is the vehicle, lower are the losses. Fuel type dummy, losses are higher for a fuel type D. That is the answer, and in 1 hour we are able to not only download but actually do a statistical analysis and come up with a decision that what kind of people we should charge higher premium for insurance, and for other people we should charge lower premium because of the factors responsible for losses in insurance. That brings us to the end of this webinar. I hope you liked it. It was all based on practice. Feel free to post any questions in next 10 minutes as I'll be present. There's a question by Roshan. What is the negative number indicating? A negative number says the total losses will be reduced if you increase the coefficient. For example, average age going up, which means that it's a negative number. If I increase average age, the total number is -5 into that age. So the loss formula, the loss equal to -5 into average age reduces. Yeah, average age is decrease in loss. Thank you very much for your patience and attending this webinar. Thank you.